Hey everyone, and welcome. Today we're diving into a powerful strategic tool that places like NASA and top-tier car manufacturers use to answer one huge question. How do you stop a disaster before it even has a chance to start? This isn't about crisis management, nope. It's about systematically designing failure right out of the equation from the very beginning. Let's get into it. So this is it. This is the question that every leader, every project manager, really every single person on a team needs to be asking. It's not enough to be great at fixing things when they break. The real genius, the real value is in building systems so solid that they just don't break in the first place. But how on earth do you do that? Well, let's be real. In any complex project, any big system, failure isn't just a possibility, it's pretty much an inevitability. The trick is to have a structured, repeatable method for finding those weak spots before they find you. And that is exactly the tool we're going to unpack today. Okay, so before we can even begin to manage failure, we have to define it at its most basic level. In this world, we call that a failure mode. Just think of it as any potential weak link in the chain, any tiny chance for a defect or a mistake to sneak into your process. Once we can identify these little building blocks of risk, we can start to build a real defense. And here is the tool that puts it all together. Failure Mode Effects Analysis, or FMEA for short. It's basically a proactive, team-based game plan to look into the future, spot those potential failure modes, figure out how bad they could be, and then, this is the important part, figure out how to stop them in their tracks. It's the strategic answer to that big question we started with.
Now, FMEA isn't some rigid, one-size-fits-all thing. It's actually a super flexible framework that you can apply through 3 different and very distinct lenses. So depending on what you're looking at, is it the product, the process, or the whole system, you're going to use a different flavor of FMEA. Let's break them down. First up, you've got the design FMEA or DFMEA. This one happens way back at the blueprint stage. So picture a car company looking at a new airbag design. They'd be asking questions like, could this material get brittle over time? Or what if the sensor totally fails in freezing weather? This is all about finding the flaws in the design itself, long before a single part ever gets made. Next up, we have the process FMEA, or PFMEA. So the airbag design, it might be absolutely perfect, but what about the assembly line that actually builds it? A PFMEA asks things like, could a robot accidentally misalign that sensor? Or could a technician grab the wrong kind of screw? It's focused entirely on the manufacturing and assembly process. And what's really important here is that you do this after the design is locked in, because, of course, the process totally depends on the design. And finally, there's the system FMEA. This is the 30,000-foot view. It's not just looking at the airbag or just the assembly line. It's looking at how the airbag system talks to the car's main computer and the braking system and the seatbelt sensors. The biggest, most catastrophic failures often happen in the gaps between the components. So this analysis happens super early on to make sure the whole orchestra is playing in tune. Okay, so we've identified all the things that could go wrong. Great. But not all risks are created equal, right? How in the world do you decide what to fix first? This is where FMEA gets really, really powerful. It gives you a way to turn that fuzzy, abstract idea of risk into a cold, hard number that you can actually work with. Every single potential failure mode gets graded against 3 simple criteria. First, severity. If this actually happens, how bad is it going to be? Second, occurrence. How likely is it to happen in the first place? And third, detection. How good are we at catching it before it gets to the customer? Each of those 3 things, severity, occurrence, and detection, gets a score, usually on a simple scale from 1 to 10. A 1 is the best you can hope for, low impact, super rare, or super easy to catch. A 10 is, well, your worst nightmare. Now, obviously, this is a bit subjective, which is exactly why FMEA is a team sport. You've got to get your experts in a room to agree on these numbers. So once you have those 3 scores, you get to do some simple math to calculate the risk priority number, or RPN. You just multiply them, severity times occurrence times detection. And that one number, which can be anywhere from 1 to 1,000, gives you a beautifully objective way to prioritize your work. The higher the RPN, the bigger the fire you need to put out first. All right, so we've covered the what and the why. Now let's get down to the how. Running an FMEA isn't some vague academic thing. It's a clear, step-by-step playbook that any team can follow. Let's walk through it. The playbook has 5 main steps. Step 1, map it out. You need a detailed flowchart of your process or a list of all your components. Step 2, brainstorm. Get the team together and list every possible way each step or part could fail. No bad ideas here.
Step 3, score it. For every single failure mode you came up with, you assign those 3 scores for a severity, occurrence, and detection. Step 4, calculate. You do the multiplication to get that all-important risk priority number. And finally, step 5, act. You use that RPN to figure out your priorities and build a concrete plan of attack.
Okay, theory is great, but let's make this real. We're going to walk through a quick, real-world example to see how all these numbers and steps actually lead to some incredibly powerful insights. So just imagine a company that's standing up a brand new customer support department. They want to get ahead of the game and find any weaknesses in their new Level 2 support process before they go live. So they decide to run a process FMEA. So the very first thing the team does is map out their process. They identify these 5 high-level steps, from the moment they get the case from level 1 all the way to either solving it or bumping it up to level 3. This simple map becomes the foundation for everything that comes next. Okay, after all the brainstorming and scoring, this is what their analysis chart looks like. Now check this out. This is where the magic happens. Look at that top line. Inaccurate analysis of logs. Its severity score is a 9. That's really bad. But look at the one below it. Customer cannot run diagnostic. It's way more likely to happen with an occurrence score of 7. But when you multiply all the factors together, that log analysis pops out with an RPN of 216, making it the clear #1 priority. And that is the absolute power of FMEA. It shows you the risks that are the most dangerous combination of factors, not just the one that's the most common or the most severe by itself. So the team has its prioritized list, the analysis is done, but here's the thing. The work is just getting started. A finished FMEA spreadsheet isn't the final trophy. It's the starting pistol for strategic action.
And this brings up a really crucial point. That RPN number is a guide. It's not a dictator. As the American Society for Quality says, the team has to use its own experience and judgment. For example, what if the second highest risk on your list is super cheap and easy to fix? You might just knock that one out first for a quick win. The FMEA is a tool to inform your expert judgment, not to replace it.
The whole FMEA process has to end with 3 very specific things. First, a list of recommended actions designed to bring those RPN scores down. Second, an owner assigned to every single one of those actions. You gotta have accountability. And third, for any risks you just can't get rid of completely, you need a documented response plan so you're ready to go if that failure happens anyway. And that pretty much wraps it up. FMEA is an incredibly powerful way to get ahead of risk. It forces you to think systematically about what could go wrong so you can put your resources where they'll make the biggest impact. So I'll leave you with this question to chew on. In your own work, in your company, what's the most critical process that you're just not analyzing?